One of the things that's been difficult or challenging in converting word equations to chemical equations using formulas is translating the words, the names of the compounds into chemical formulas. And so, for example, if we have a word equation that reads barium fluoride, reacts with iron 2 oxide to form, etc., etc., the first hurdle that we're faced with is translating these compound names into formulas, and that that can give us a little bit of anxiety. And so the purpose of this session is to get a little bit of practice translating ionic compound names into formulas, and I think if we can get some practice with this, we're going to feel a lot more comfortable with these chemical reactions. So in this video, we're going to specifically focus on compound name to compound formula conversions. So let's start with number one. I think you have a worksheet where the first compound is barium fluoride. So barium fluoride, okay. The first step is to realize that barium, the chemical formula is, or the chemical symbol is Ba. Fluorine, which becomes fluoride in the ionic compound, is F. And so now we need to go over and check our periodic table. So hopefully you have a periodic table at the ready. If not, push pause, go get one. But when you have one, you'll see that barium is down in the lower left-hand corner of the periodic table. It's in group 2A. So it's just to the right of cesium. It's directly under strontium, and because it's in group 2A, it has a 2+ charge. Okay, fluorine, as you can probably see, is in the upper right-hand corner. It's in group 7A. It only needs to gain 1 electron to have a noble gas valence shell, and so in the ionic form, it's going to take on a charge of 1-. So when we then go to write the chemical formula, you can think of it as the crisscross method. The 2 in the charge for barium goes down here to be the subscript on fluorine. But in a more physical sense, in terms of balancing charges, you can see that it takes 2 fluorines to balance the charge on a barium. So for that reason, you need a subscript of 2 here. Okay, so to get from the name to the formula, it is BaF2. Okay, so that's number 1. All right, let's go over here and tackle number 2. This is iron 2 oxide. Okay, iron 2 oxide. Now, iron is a transition metal, and as is the case with a lot of transition metals, they can take on more than 1 charge, depending on what compound it's in. And so we use the so-called stock naming system, where we use a Roman numeral to indicate the charge on the ion. So because there's a Roman numeral 2 here, that indicates that the charge on the iron in this compound is 2+. Oxide, that's oxygen, that's always 2-. Okay, why? Because it's in group 6A, and so it has to pick up 2 additional electrons to adopt the electron configuration of neon, the nearest noble gas. Okay, so because they have equal and opposite charges, the formula is simply a 1-to-1 ratio. So FeO would be the chemical formula for iron 2 oxide. Okay, so how are you doing? I hope you're doing okay on this. All right, number 3. potassium sulfide. So I'm going to now, just to save time, I'm not going to write the name because you have that on your worksheet. Potassium sulfide. So we know that is a K for potassium, S for sulfur. All right, what's the charge on potassium? Well, it's in the first group, right? Group 1A, so it's going to take on a single positive charge. What about sulfur? Can you find sulfur? It's directly under oxygen. It's group 6A, and so like oxygen, usually sulfur takes on a 2- charge. So what that means is that it's going to take 2 potassium single pluses to balance the charge on sulfur 2-. And so the final formula would be K2S, and that is the formula for potassium sulfide. Okay, number 4, iron 3 oxide. Okay, so iron, the Roman numeral 3 tells you that there is a 3+ charge on iron. Again, oxygen, you can pretty much count on oxygen to have a 2- charge. Now, full disclosure, there are a few compounds where the oxygen is going to have say a single minus charge, but most of the compounds we're going to run into, it is 2-. Okay, so here, this is a good case for the crisscross method. So the 3 on the charge for iron comes down here, becomes the subscript for oxygen, and the 2-, that 2 comes down here to become a subscript 2. So the formula for iron 3 oxide is Fe2O3. All right, let's go on to number 5. Just checking my time. Okay, we're doing good. Lithium bromide is number 5. Lithium bromide. Okay, so lithium, let me get my pen back. Lithium is in group 1A, so that is a single plus charge. Bromine is like fluorine is in group 7A, and therefore it's going to have a single minus charge. So in this case, 1-to-1 ratio is what we need. So LiBr is the correct formula. Number 6, chromium 3 sulfide. Okay, so Cr. What's that Roman numeral 3 mean? That's right. It means there is a 3+ charge on chromium. Oops, wrote down the wrong element. So that's chromium 3 sulfide. Sulfur, as we know, 2-. Therefore, so what method are we going to use to determine our subscripts? If you said crisscross, you are correct. So that is Cr2S3. Okay, see how these guys crisscross. Okay, Cr2S3. Okay, so now I'm going to clear the plate here so that we can go to number 7. All right, number 7 is aluminum iodide. Okay, aluminum iodide. Aluminum, that is not a transition metal. It's just a regular metal. It's in group 3A. So it's kind of it's over just to the right of the transition metals. So sometimes that one it's easy to forget about. But it's in group 3A. It's a regular metal, and you can pretty much always count on it having a 3+ charge. Iodine, again, it's in the halogen group 7A, so single minus. Therefore, it's going to take 3 iodines to balance the positive charge on aluminum. So the correct formula for the ionic compound is Al-I3. All right. Okay, number 8, copper 1 chloride. Okay, copper. The Roman numeral 1 means a single positive charge. Chloride, that's a halogen, group 7A, just like iodine, so single minus. Therefore, copper 1 chloride is simply CuCl. Number 9, zinc 2 sulfide. All right, zinc is Zn. Roman numeral 2 means positive 2 plus. Sulfide, again, 2 minus. You can see that a 1-to-1 ratio, 2 plus 2 minus equals 0. So the neutral ionic compound is simply ZnS. Number 10, copper 2 chloride. All right, so this time, unlike number 8, in this compound, the charge on the copper is 2 plus, chloride single minus, as we've seen, and therefore it takes two chlorines, 2 chloride anions, to balance the charge on the copper cation. So that's CuCl2. All right, take a breath. I hope you're starting to get the hang of it. Hopefully it's starting to seem a little bit more natural. Let's go to the next section of your worksheet, where now we're going to go in the opposite direction. Okay, so you've been given the chemical formula, and now we want to translate that back to a name. So here we have Ag2O. So for this, silver, if you can take a look at your periodic table, you'll notice that silver is one of the transition elements, one of the transition metals. It's directly under copper, and but unlike a lot of transition elements, it usually takes on a charge of a single plus. Okay, but even if you didn't know that, you could fall back on oxygen, and you know that oxygen is pretty much always 2 minus. So therefore, if the formula tells you that you have 2 silvers, then they each must be single plus in order to balance the 2 minus charge. Okay, and one way to kind of think of that in a kind of a graphical sense is, if this is the oxygen atom and it has a 2 minus charge, and we have 2 silver atoms, each with a single plus, it's going to take 2 of these guys to balance the -2 of the oxygen. So that's another way of kind of determining that the charge on each silver is single plus. So when we write the name, that would be just silver. And usually, okay, like if you're following the rules for the stock system, you would say silver, Roman numeral 1, oxide. And that would be fine. I would be happy to accept that. Although in the literature and in textbooks, because silver pretty much always has a single plus charge, the Roman numeral is usually not included in the name. Okay, but I'll accept either on that. Okay, number 12. You've been given PbO. Okay, Pb is lead. Again, oxygen. You know that oxygen is always 2 minus. Therefore, this lead cation must be 2 plus to have a neutral unit here. So this must be lead 2 oxide. All right. Okay, so the Roman numeral 2 reflects the fact that this lead is a 2 plus cation. All right, let's go to the next page. The next problem. So I'll tell you what, I'm going to need to close this out because I'm just about at my 15-minute limit. And in part 2 of this session, we'll tackle compounds 13 through 16. Okay, so I'll see you there.